consider the first example on the board. The question is, find the relative or the local maximum and minimum point of the function y is equal to x raised to the power of 3 minus 6x squared plus 24. Solution. The function is y is equal to x raised to the power of 3 minus 6x squared plus 24 plus 24. To determine the maximum and the minimum point is very simple once you note these 5 steps that I'm going to give to you. Now the first step is we are going to differentiate the function given on the board. That is, find the y over the x. After getting the y over the x, then step number 2, determine the stationary point or the turning point. And to get the stationary point, we must equate the y over the x to 0. Then at that point, that is where we can determine the value of x. Step number 3, determine the 2y over the x squared from the y over the x. And step number 4, we are going to substitute the value of x obtained in step number 2 into the 2y over the x squared. That is the point where we will determine if a function is maximum or relative minimum point. After getting the step number 4, or getting the relative maximum and relative minimum point, the last step, which is step number 5, is to substitute step 4, the values obtained in step number 4, into. So let us begin with step number 1. So we are going to differentiate this function on the board, and if I differentiate this function, I will have 3 times this term. That will give me dy over dx is equal to 3 times this is 3, x subtract 1 from the power, which is 2, minus 2 times 6 gives 12, subtract 1 from the power, which is x. Now if you differentiate a constant term, it will give you 0. So dy over dx becomes 3x squared minus 12. Step number 2, what is the value of x at turning point? So step 2, and at stationary point or at turning point, the y over the x must be equal to 0. So that means we are required to equate this to 0 and determine the value of x. So 3x squared minus 12x is equal to 0 at turning point. And if I simplify this equation, I will have divide this by 3. That will give me x squared minus 4x is equal to 0. Then factorize. I will obtain x minus 4. This is equal to 0. Now let's check. X times x gives x squared. X times minus 4 gives 4x, which is equal to 0. At this juncture, we can equate x to 0 and also equate x minus 4 to 0. So x is equal to 0 from here, or over here, x minus 4 is equal to 0. X is equal to 0, or over here, if you make x the subject, x is equal to step number 3. Step 3 is to find the 2y over the x squared. Now to determine the 2y over the x squared, we have to differentiate this function over again. That means the 2y over the x squared will equal to, if I differentiate this, I will get 2 times 3, which is 6. Then subtract 1 from the power, which is 6x. So we have 6x minus, if I differentiate 12x, I will have 12 minus 12. Now, step number 4, this is the stage where we can either determine if a function is relative maximum or relative minimum. Step 4, substitute the values of x obtained here into this equation on the board. So we are putting x as 0 into this. Likewise, as we put x as 4 into this, respectively. Step. So that would become 6x minus 12 at x equal to 0. At x equal to 0, let us see if the function is going to be maximum or minimum. So that becomes 6 bracket open 0 minus 12. This gives 6 times 0 is 0, and minus 12 gives minus 12. Now at x equal to 0 on the board, the 2y over the x squared is minus 12. Let's recall these principles on the board. In these principles on the board, we observe that when the 2y over the x squared is less than 0, such as minus 12 on the board, the function is said to be maximum. So maximum, relative maximum point at x equal to 0. We obtain maximum point at x equal to 0. Let's substitute x equal to 4 into this equation. So at x equal to 4, then it will become 6 bracket open 4 minus 12 equal to minus 12. 6 times 4 is 24, and 24 minus 12 gives 12. So we obtain 12 at this point. Let us consider these principles again. Now in these principles, we observe that at x equal to 4, the 2y over the x squared is 12, which is greater than 0. Because the 2y over the x squared is greater than 0, we can conclude by saying the minimum point is attained. Minimum point at x equal to 4. At x equal to 4. Now to find the maximum point and the minimum point respectively, we are going to substitute x equal to 0 into the original function which was given to us as this. Also, to determine the minimum point, we are going to substitute x equal to 4 into this original function that was given to us. At x equal to 0, we obtain the maximum point. So let's substitute y is equal to x raised to the power of 3 minus 6x squared plus 24. That was the function given to us. So y is equal to 0 raised to the power of 3 minus 6, 0 raised to the power of 2 plus 24. This is equal to, everything gives 0 minus 0 raised to the power of 2 is 0, and times this, which is 0. plus 24. Relative maximum or local maximum point is given as 24 at this point. Minimum point at x equal to 4 on the board. So let's substitute. If I substitute, I will have y is equal to 4 raised to the power of 3 minus 6 4 raised to the power of 2 plus 24. 64 minus 6 times 16 is 96 plus 24. Y is equal to minus 8. Now maximum point is maximum point is at x we obtain 0. At x we obtain 0. So we have 0. Then at y we obtain 24. 24. Minimum point is at x we obtain 4, and at y we obtain minus 8.